Hey everybody, welcome to June 3rd. Is Wednesday, June 3rd. We're going to start a new lesson today with our graphical representations of data. Um, we're starting with a new lesson, analyzing numerical data displays. Okay, so a couple of things that we're going to be doing with them is different types of graphical representations and data displays. Warm-up's asking about Mrs. Garcia's class. Every one of these little animals or symbols equals one student. These were something that we used a tremendous amount in third grade. It's called a pictograph. And you can use a symbol to represent everybody who votes for any of the categories. So this would be qualitative data, right? Because it is not numbers, it's actually categories or categorical data, is what we also called it yesterday. So we're going to be doing representations like that, although be slightly more sophisticated. And so as we go through, I just wanted to highlight some of the things that we're taking a look at here. The first thing that we're going to take a look at here are called box plots. Okay, so we've got these different graphical representations, and I'm not going to go through the problems with you or make you do the problems. I just want to show you that, like, if we're talking about rock climbing times, we can list all the different times that they have here and then put an X that represents 1, 2, 3, or 4 students, however many you need to scale appropriately your graph. And so take a look at how these are set up and how easy they are to read once you've gone ahead and found all the different times. All right. So we're going to look at some dot plots, all right, and talk a little bit about the different dot plots as we go into activity 1.1. But let's take a look at the definition and a worked example. One way to describe a set of quantitative data is by drawing a graphical display of the data. So a dot plot is one of the ones that we can use. And basically everything that you have here is just your x-axis down here. If you were to graph this out on a line or some type of observation, this would be your x-axis. They're independent. This is one of your variables here, and it's the number of medals won, and then you can represent all the different people that got that number of medals. So you can see 5 people, they got 0 medals. 5 people got 1 medal. Okay. 2 people got 3 people got 2 medals. And then all the way over here, one person had a really good Olympics. They got 13 medals. Now you could also make each X worth 2 people or 3 people. So you can change the scale of the graph as well. Right? And that's how we use a box plot or a plot diagram. One other thing that I wanted to show you today is just kind of describing different distributions. And all the distribution means is it's the overall shape of the graph or how the data is distributed out over the graph. And there's different ways to look at it. It could be symmetric, skewed right, skewed left. Okay, and we're going to talk about those things as we build our graphical representations. So if we were looking at box plot diagrams or plot diagrams, and you can see how this one is set up. You've got low values on the outside and higher values on the middle. This one would be called symmetric, and we call it that way because it almost looks like a bell curve, right? It looks very symmetric. As we go to the middle, we get more and more observations, and then we go back to the highest. We get less and less observations. So let's use our precise mathematical vocabulary. As we start with the minimum observation, it gets higher to the mean mode or average, whatever you're using in the middle. And then as you get to the max observation, the number of observations come down. So this one is kind of skewed right. All right. So this one is going to have less observations to the right, more observations to the left. This is kind of like that medal one we looked at. There were a lot of people that got 0 or 1 medals. And then as the number of medals went higher, fewer people achieved the higher number of medals. And then skewed left is just the opposite. With the lower values, you have lower number of observations. The higher values, you have higher numbers of observations. So we're going to look at those terms as a way for us to describe data as well. All right. And then there's some few things we're going to look at: clusters, gaps, peaks, outliers. Remember that word. That's when we have a big, large number or a very small number in comparison to the most of the data. And we'll talk about that one with our next examples. So, all right, Let's just scroll down. That puts us through this. I want you to look at the data that I've collected. Remember, I went through those 3 questions, and here's some of the things we're going to do. So first of all, at the end of today, you're going to go ahead and answer this question. Create a table using the data that you collected yesterday. So I asked you to have a question, ask 20 people the question, and upload your table. Once you take the data that you had, create a table, and then upload it for today's assignment. So you should have your data from yesterday, and then you can create a table, upload it. I'll show you one way to do it. You can do it on paper and pencil and send me a picture. I did it using Google Sheets. So let's take a look at the first one here. This was the one that was the height, okay? So this is quantitative data because we're looking at the height in inches, right? We start at 48, 49, 50. If we were to make a box plot, it's starting to look pretty symmetrical, right? And as we get to these higher and into the high 50s and low 60s, we're getting a lot of observations. And then as we get bigger or taller, we have less observations again. So this is a pretty symmetric distribution of data if we were to go ahead and do a dot plot diagram. Notice how we have somebody who's 79 inches. Using my math, that's 6 feet and 7 inches. I'm guessing Mr. Selk put this one out there. Mr. Selk in our data, because we go from 48 to 68 with all of our observations except for one, and then he's a full 11 outside of our highest observation. Mr. Selk is an outlier, and we know that because when we watch him walk around the halls, he's really, really tall, right? So that makes him an outlier when compared to our heights within the grade. Okay, so you're going to make a table like this. All right, this was a great table for quantitative data, and our question about height in inches was a great question for quantitative data. We also had this one right here, right, where we created a table of, this is categorical data. What part of your life do you miss the most? The nice thing about Google Sheets, and we'll go a tutorial on this later, is I can go ahead and sort this really easily by selecting my data, hitting sort range. Okay, I'm going to sort by the answer to the question from A to Z, collect, sort, and it went through and it did everything we had here, right? So here's our first category. I can copy it right here. I can paste it right here. And there were 1 people that made that their top one. Hanging out with friends. This one was, oh my, you guys really miss hanging out with friends. Control C, that's 91. So that's 3 from 91. That's 88 observations. I'm going to copy one of them. I'm going to take it up here, and I'm going to make the chart with it. And that's 88. Okay, so now that goes in my table. Now I can go all the way down to my next category, which is movie theaters. Movie theaters is 92 to 98, so that's 6. Control C that. Bring it back up to the top. Movie theaters is 6. Go down, we got 2 more options. We got the other, or 3 more options. We got the other. And other is 99 to 110, so that's 11. Okay. So I'm just building my table out. I'm listing out my categories and checking the number of observations. So other is 11. And then 2 more. We have school. A lot of people missing school. 111 to 125, that's 14. Bring that guy up to the top.
Thank you, Matt.
And we're going to go down here to team sports, which was 125 to 156, so that's 31. And I just made myself a table. So I want you guys to take your data and make a table. Great job, you guys. Thanks for hanging there. This one was a little bit longer than the other ones. But get your table done, and we'll get ready on the next stuff tomorrow.